mobile computing. Now we'll see the next chapter, that is the mobile network layer. So in that we'll discuss about the mobile IP and DHCP. Now first we'll discuss motivation behind the mobile IP. So first, before going to the motivation, so mobile computing is clearly the paradigm of the futures, and the internet is the network for the global data communication with hundreds of millions of users. So why not simply use the mobile computers in the internet? So this is the question mark. So the reason is quite simple. You will not receive a single packet as soon as you leave your home network. That is the network your computer is configured for, and reconnect your computer, right? Or wireless or wired. So at another place, if no additional mechanisms are available, the reason for this is quite simple. If you consider routing mechanism on the internet, that is if you want to send the through internet any data, so that is based on the IP destination address, right? So the host sends an IP packet with a header containing the destination address with the other fields, right? And the destination address not only determine the receivers of the packet, but also a physical subnet of the receiver, right? Or network prefix. So for example, 129.13.42, so determine the physical subnet, right? Or for example, again we'll consider the destination address, that is the 129.13.42.99, shows that the receiver must be connected to the physical subnet with the network prefix, that is 129.13.42, right? Now router in the internet now look at the destination address of incoming packets and forward them according to the internal lookup tables. Now to avoid an explosion of routing table, only prefixes are stored and further optimizations are applied. So a router would otherwise have to store the addresses of all the computers in the internet, so which is obviously not feasible. So as long as the receiver can be reached within its physical subnet, it gets the packet. As soon as it moves outside the subnet, packet will not reach it. A host needs so-called the topologically correct address. Host needs the topologically correct address, right? So change of physical subnet, change of IP address to have a topologically correct address, or you can call them as a standard IP also. Now we will not get the mobility, then we need to think about the different kind of solutions, right? So here the solution is temporarily change routing table entries for mobile host, and another one the change mobile host IP address, right? So one might think that a quick solution to this problem would be to assign the computer a new topologically correct IP address, right? But this is what many users do with the help of DHCP, right? But so moving to a new location means assigning a new IP address. The problem is that nobody knows about this new address. Now it is almost impossible to find a mobile host on the internet, so which has just changed its address, right? So one could argue that with the help of dynamic DNS and update of mapping logical name, that is IP address, is also possible. So this is what many computer user do if they have a dynamic IP address and still want to be permanently reachable using the same logical computer name. Now here it is very important to note that these consideration, most of mobile IPs motivations are important. If a user want to offer services from the mobile node, that is the node should act as a server, right? So typically the IP address is of no special interest of service uses. In this case, in that case, the DHCP is sufficient, right? So another motivation for the permanent IP address is emergency communication with permanent and quick reachability via the same IP address, right? So what about dynamically adapting the IP addresses with regards to the current locations, right? So adjust the host IP address depending on the current locations, right? So the problem is that the domain name system DNS needs some time before it updates the internal tables necessary to map the logical name to an IP address. This approach does not work if the mobile node moves quite outdated. The internet and DNS have not been built for frequent updates. Just imagine millions of nodes moving at the same time. So DNS could never present a consistent view of names and addresses, as it uses the caching to improve the scalability, right? And it is simply too expensive to update quickly, right? So if you go for the quick updation, so there is a severe problem with higher layer protocols like TCP, which relies on the IP addresses, right? Changing the IP addresses while still having the TCP connection open means breaking the connections, right? A TCP connection is identified by the tuples. Tuple means source IP address, source port, destination IP address, destination port, and also known as a socket pair also. And socket consists of address and ports. So therefore, a TCP connection cannot survive any address change also, right? So breaking TCP connections is not an option. Now using even simple program like telnet would be impossible. The mobile node would not also have to notify all communication partners about the new address in that case. Another approach is creation of specific routers to the mobile nodes, right? And router always select the best fitting prefix for the routing decisions, right? So if router now has the entry for the prefix 129.13.42 and address 129.13.42.99, it would choose the port associated with the latter for forwarding. If packet with the destination address, that is 129.13.42.99 comes. So while theoretically, it is possible to change the routing table all over the world to create the specific routes to the mobile node. This does not scale at the all with the number of nodes in the internet. Now, routers are built for extremely fast forwarding, right? So, routers work is fast forwarding, but not for the fast updates of the routing tables, right? So while first is done with the special hardware support, latter is typically piece of software which cannot handle the burden of the frequent updates, right? So routers are the like brains of the internet, so holding the whole net together, right? No service provider or system administrator would allow the changes to the routing table, probably sacrificing the stability just to provide the mobility for individual users. So these are the reasons for the mobile IP. So why we are going for the mobile IP? Now requirements to the mobile IP. A quick solution does not work. A more general architecture has to be designed for this. Right? So many field or trial and proprietary systems finally lead to the mobile IP as a standard to enable the mobility in the internet. Right? So the several requirements are considered in case of the development of the standard. So in that, the first one is the transparency, compatibility, security, efficiency, and scalability. Right? Transparency means the mobility should remain invisible for many higher layer protocol and applications. Right? So maybe noticing a lower bandwidth and some interruption in service. Higher layer should continue to work even if the mobile computers has changed its point of attachment to the network, right? For TCP, this means that the computer must keep its IP address, right? Already we discussed in the motivational part. Now, if the interruption of the connectivity does not take too long, the TCP connection survives the change of the attachment point. Right? So many of the today's application have not been designed for use of the mobile environment. So the only effect of mobility should be higher delay and lower bandwidth, right? So there are some applications for which it is better to be mobility aware. For example, cost-based routing or video compressions, right? So currently possible to use the different network softwares could select the cheapest one, right? So of course, if a video application knows that only low bandwidth connection is currently available, it could use the different compression scheme, and additional mechanisms are necessary to inform these applications about the mobility. This is about the transparency requirement, or this is the transparency requirement. After that, if we talk about the compatibility, no changes to current host, operating systems, and routers. Mobile end system can communicate with the fixed systems, right? Compatibility, the installed base of internet computer means that is the computers running TCP IP and connected to the internet is huge. New standard cannot introduce the changes for applications or network protocol already in use. People still want to use their favorite browser for worldwide www, and do not want to change the application just for mobility, and the same hold for operating system also, right? The mobile LP has to be integrated into the existing operating systems, or at least work with them, right? So today it is available for many platforms. Routers within the internet should not necessarily require other softwares. So while it is possible to enhance the capabilities of some routers to support the mobility, it is almost impossible to change all of them, right? So this is about the compatibility. Now again, security. So authentication of all registration messages. So mobility raises many security problems. A minimum requirement is that all messages related to management of the mobile IP are authenticated, right? The IP layer must be sure that if it forwards the packet to mobile host, that this host receives the packet, and the IP layer can only guarantee the IP address of the receiver is correct or not, right? There are no ways of preventing the fake IP addresses or other attacks, right? So in case of the security is concerned, and the fourth requirement is the efficiency and scalability, right? So only few additional messages to the mobile system with low bandwidth, global support for large number of mobile systems, right? So introducing new mechanism to the internet must not affect its efficiency, right? So these are the four requirements to the mobile IP, right? So we discussed here. After that, we'll discuss few of the terminology, and after that we'll go for the network. Some entities and terminologies which we are using in the mobile IP network or in the network, right? So first, mobile node. Mobile node means a mobile node is an A system or a router that can change its point of attachment to the internet using the mobile IP. Or MN, mobile node keep its IP address and can continuously communicate with any other system in the internet as long as link layer connectivity is given here, right? Laptop, PDA, etc. that may move about. Home agent, the router in home networks of the mobile node helps in forwarding or registers the current mobile network location, sorry, mobile node locations, tunnels the IP datagram to COA. COA means care of address, right? Third terminology, that is the foreign agent. Foreign agent, the role of foreign agent is the current subnet of the mobile node, which is and which is not the home network, right? A router in the current foreign network of the mobile node forward the tunneled datagrams to the mobile nodes, right? Care of addresses. Next is the care of addresses. Now, care of address, in short, we are calling them as COE. So that defines the current location of the mobile node from an IP point of view. All IP packets sent to the mobile node are delivered to the COA, not directly to the IP address of the mobile node. Right? So packet delivery towards the mobile node is done using the tunnel, right? And COA marks the tunnel endpoint, that is the address where packet exists the tunnel, right? After that, corresponding nodes. Corresponding node is the partner of the mobile node in communication, right? CN represent these partners for the mobile node, and the CN can be fixed or mobile node. A node that want to communicate with the mobile nodes, right? So here is the example network, right? Home agent HA, home network, router, physical home network for the mobile node, right? So internet, so here foreign network, foreign agent router, right? So MN mobile node again. Now current physical network for the mobile node. Now here physical home network for the mobile node router and aid system CN, or we are calling them as a corresponding node. So this is the example network. Next, same diagram, we will discuss the overview. So here in the diagram, so whatever the terminology we discuss, all these terminologies are shown in the diagram. Home network, router, home agent, COE, care of address, right? Router, foreign agent, router, right? Mobile nodes, foreign networks, home network. The same example is represented in the form of block, right? CN means corresponding node routers. Now there are two different possibilities for the location of the care of address. So one is the foreign agent care of address, and another one is the co-located care of address, co-located care of address, right? So home agent HA, that provide the several services for the mobile node and is located in the home network, and the tunnel for packet towards the MN start at the home agent HA, and the HA maintain the location registry, that is it informs of the mobile node's location by current COA, right, to the current COA. Now here is the overview of the network. Now if we talk about the IP packet delivery, so how the packet is delivered, right? Now here the figure shows the packet delivery to and from the mobile node using the example network, right? So here the same network we will consider the step number one. Here step number one, the correspondent node CN, right? CN, this is the correspondent node CN, want to send an IP packet to the MN, right, mobile node. So one of the requirement of the mobile IP was to support hiding the mobility of the mobile node. CN does not need to know anything about the mobile node's current location and send the packet as usual to the IP address of the mobile node, right? So this is the step number one. Step number two, so here the CN sends this corresponding node, sends an IP packet with the MN as a destination address and CN as a resource address, right? So here MN as a destination address and CN as a source address, right? So the internet not having the information on the current location of the mobile node, so route the packet to the routers responsible for the home network of the mobile node, right? So this is done using the standard routing mechanism of the internet in the step number 2. Now here home agent now intercept the packet knowing that the mobile node is currently not in its home network, right? And the packet is not forwarded into the subnet as usual but encapsulated and tunneled to the COA, care of addresses, right? And new header is put in front of the old IP header showing the COA as a new destination and HA as a source of the encapsulated packet. Now this is about the step number 2. In the step number 3, the foreign agent now decapsulate whatever the encapsulation is done in the step number 2. So decapsulate the packet, that removes the additional header and forward the original packet with the corresponding nodes as a source and mobile node as a destination to the mobile, as a mobile node as a destination, and that will be sent to the mobile node, right? So in the step number 3 and step number 4, now again after receiving this packet, reverse, right? So again for the mobile node mobility is not visible, right? So sender sends to the IP addresses of the receiver and foreign agent is default routers, right? So sending packet from the mobile node to the CN is much simpler, right? The mobile node sends the packet as usual with its own fixed IP address as a source and CN address, corresponding node's address as the destination. So this is the IP packet delivery is done in the network for packet delivery to and from the mobile. Next is the network integration. Now agent advertisement right? So one initial problem of the mobile node after moving is how to find the foreign agent. Now, how does the mobile node discover that it has moved from one location to another location? Now, for this purpose, the mobile IP describe two methods. One is the agent advertisement and agent solicitation, right? So here the foreign agent and the home agent advertise their presence periodically using the special agent advertisement message, right? So they are advertising their self. Now this advertisement message can be sent as a beacon or broadcast into the subnet. Now for this advertisement, so internet control message protocol messages according to RFC are used with the submobility extensions. Routers in the fixed networks, so implementing this standard and also advertise their routing service periodically to the attached link. So this is about the agent advertisement. After that, registration always limited lifetime, right? So mobile node signals the care of address to the HA via the foreign agent, and HA acknowledges. The messages need to be secured by authentication. Advertisement, HA advertises the MN IP addresses as for the fixed system. Routers adjust their entries. EHA responsible for a long time. Now all packets to the MNs are sent to the EHA. So here agent advertisement is done periodically, right? Now how the registration is done, so that we will discuss here. Registration, right? So registration can be done in two different ways depending on the location of the care of address, right? Now if the care of address is at the foreign agent, right, the registration is done as shown in the this first figure, right? So if the COA is at the FA, so registration is done, which is shown in the this first left side of the diagram, right? So the mobile node MN sends its registration request containing the COE to the foreign agent, which is forwarding the request to the home agent, right? And the home agent now set up mobility binding containing the mobile node's home IP address and the current COE. Additionally, mobility binding contains the lifetime of the registration, which is negotiated during the registration process. Right? So that the after some time, so registration expires automatically after the lifetime, or it is deleted also, right? So the mobile node should register before expiration or before expiry. So this mechanism is necessary to avoid the mobility binding which are no longer used. Right? So after setting up the mobility binding, the HA home agent sends a reply message back to the foreign agent FA, which forward it to the MN, right? So FA will forward it to the MN. So this is the one way for the registration, and another way two is here. It's shown in the right side diagram. If the COE is co-located, if COE is or care of address is co-located, the registration can be simpler. So as shown in this figure, right? The mobile node may send the request directly to the home agent and vice versa, right? So is also the registration process for the mobile node returning to their home network, right? So here they also register directly with the home agent. If the mobile node receives an agent advertisement from the foreign agent, so it should register via this foreign agent. If the registration R bit is sent in the advertisement, right? So this is about the registration. So two ways of the registration we discussed here. Next is the encapsulation. Next part is the encapsulation, right? So tunneling or encapsulation, right? So encapsulation of one packet into the another as a payload, right? The tunnel establishes the virtual pipe for the data packets between the tunnel entry and the tunnel endpoints, right? The packet entering in the tunnels are forwarded inside the tunnel and leaves the tunnel unchanged, right? So tunneling. That is sending packet through tunnel is achieved by using only encapsulation, right? So here figure shows the IP encapsulation. So encapsulation is the mechanism of taking packets consisting of packet headers and data and putting it into the data part of the new packets, right? And the reverse operation is taking packet out of the data part of another packet is called as a decapsulation. Now encapsulation and decapsulations are the operations performed when the packet is transferred from a higher protocol layer to the lower layer or from the lower to the higher layer respectively. Now here these functions are used within the same layer, right? So here this figure shows exactly what the home agent at the tunnel entry does, right? So new IP headers, outer headers, right? So new data, inner headers, and original data. The here the home agent takes the original packet with the mobile node destination, right? Put it into the data part of the new packet and set the new IP header, right? So new IP header is set in such a way that the packet is routed to a care of address. The new header is also called as a outer header for the obvious reasons, right? Now additionally there is an inner header and which can be identical to the original header, as this is the case for the IP in IP encapsulation, or inner header can be computed during the encapsulation. So this is about the encapsulation. Next is the optimizing of packet forwarding. Now optimization of packet forwarding. So here some problems, that is the triangular routing. The sender sends all packets via the home agent to the mobile node. The triangular routes the longer and higher latency and network load, right? So imagine here, suppose a Japanese and a German meets at a conference on any of the cities in Japan or Germany. So both want to use their laptops for exchanging the data, and both run mobile IP for mobility support. So if Japanese sends a packet to the German, so his computer sends the data to the home agent of the German, that is from uh, Havia. Some those will see consider the city Havia to Germany, right? The home agent in the Germany now encapsulate the packets and tunnel them to the care of address of the German laptop on Havia. So this means that the although the computers might be only meters away and the packets have to travel around the world. So this is inefficient behavior of the non-optimized mobile IP is called as a triangular routing. So here unnecessarily the triangle is made of the three segments, right? So from how the triangular routing is done or created, sometimes corresponding node to home agent and home agent to the care of address or mobile nodes and mobile node back to the corresponding nodes. So in this way the this triangular problem is created. Now what is the solution for this triangular problem? So in that case, the solution is the home agent informs a sender about the location of the mobile node, and the sender learns the current location of the mobile node and direct tunneling to this location. So big security problems are solved. Again, big security problems, right? So change of the foreign agents. So packets on the fly during the change can be lost, right? So new foreign agent informs the old foreign agent to avoid the packet loss, right? Old foreign agent forward the remaining packet to the new foreign agents, and update also enables the old foreign agent to release the resources for mobile node. So this is about the optimization of the packet forwarding. So mobile IP and IPv6. So mobile IP was developed for IPv4, but IPv6 simplifies the protocol. So security is integrated, not add-on. So authentication of the registration is included here. So care of address can be assigned via auto configuration. So DHCP v6 is used, right? So as a auto configuration, or is one candidate, right? So every IPv6 node master address is the auto configuration, and the mechanism for acquiring the COA are the already built in. So neighbor discovery as the mechanism. So mandatory for every node is also included in the specification, and special foreign agent are no longer needed to advertise the services, right? So combining the features of auto configuration and neighbor discovery means that every mobile node is able to create or obtain the topologically correct addresses for the current point of attachment. So here every IPv6 node can send binding updates to another node. So the mobile node can send its current COA directly to the corresponding node and home agents. So these mechanisms are integral part of the IPv6, right? So a soft handover is possible with IPv6, right? The mobile node sends the new COE to its old router, and old router encapsulate all packets for the mobile nodes, forward them to the new COE. Authentication is already granted, right? So here mobile IP in the IPv6 network required a few additional mechanism of CN, MN and HA, and the foreign agent is not needed anymore, right? The corresponding node only has to be able to process the binding updates, right? So as we discussed, that is to create or to update the entry in the routing tables, right? And the mobile network itself has to be able to decapsulate the packet to detect. So when it needs the new care of address, and to determine when to send the binding updates to the home agents and the corresponding nodes. So IPv6 does not solve any firewall or privacy problems. So For that purpose, we need to study some additional mechanism on the higher layers. So how to solve these problems. Right, now here we'll stop. Thank you.
Hopefully you might have enjoyed the lecture. Then please do like the video and know your thoughts in comments. Please do share this video among your friends and don't forget to subscribe to our channel. After subscription you can press the bell icon to never miss the notification regarding our new videos. Thank you so much.